Okay, so this question is really a homework only question, but I want to go through it. It's a good question. So it says, according to the population in 2010, the population was 22,353. And in 2020, they found that the population was 26,050. So it says, use this exponential model to write an exponential function. So the thing that's different about this is we don't really know the R value, right? So we don't, or that K value. So they represent here the growth constant K is what we need to find. All right, so what we're going to do is we're going to start with what we know. All right, so we know that T needs to be the number of years since 2020. So they do specifically say that. So in 20 since 2010. So 2010. So if I'm creating like a little T chart where I have T and then I have my end amount. Okay, so what would the situation be here? So in 2010, since T is the numbers of years since 2010, T would be 0. And in 2010, the end amount was 22,353. Then they tell us that in 2020, the T value would be 10 because it's 10 years since 2010 and 2022 or in 2020. And then it says that the population was 26,050. All right, so that's kind of our two data points that we have. We also know that it's an exponential model. Now here, because of the fact that they give you this, and then the first step or the first question is, what is the exponential model? I highly recommend not using the PERT model, but using the notation that they have given us here. So we have y is equal to y naught e to the kt. Okay, now we know that whatever number is here is the original amount. And we know from this problem that the original amount that we have is 22,353. Okay, so we know that information. So the first thing that we're going to do is we're just going to plug in the y naught. And that y naught, remember, is your original amount. So at time is equal to 0 at the very, very beginning, what was it? That is going to be your y naught value. Now, the second step is going to be to plug in this point that you have 10 comma 26,050. Okay, so here's how that's going to look. What's going to happen is the T value, remember this is the T, this is the output Y. So you're going to have that when time is equal to 10, Y is this 26,050. You still have the 22,353. You have E, you do not know K, but you know that the time variable is 10. Okay, so what I'm doing here is I'm replacing for T the 10 and for Y the 26,050, that end amount. And then from there, I can solve for K. Now you'll notice that K is an exponential equation because your variable is in the exponent. So to solve for K, I'm going to undo PEMDAS. To undo PEMDAS, my first step would be to divide both sides by the 22,353. Now, when I take out the 26,050 divided by the 22,353, gives me a crazy decimal. I don't want that crazy decimal, so I am going to keep this as, the fraction to avoid any sort of rounding. So that's going to be the 26,050 over 22,353 is equal to, and then again, this number is crossed out, so I just have e to the k times 10. So that's 10k. Now, I then need to undo, so again, I'm trying to undo PEMDAS. I undid the addition, subtraction, multiplication, division. Now I'm trying to undo the exponent. The way I undo the exponent is by taking the natural log. So I'm going to apply natural log, natural log. And then I remember that the natural log and the e have the same base, so they cross out, and that just gives us 10k on the right-hand side. And then from there, I can solve for k by dividing both sides by 10. And that gives us k is approximately equal to. Now, here's the thing. It says round at the very top. It says round the growth constant. Remember, the growth constant is basically the interest rate in the PERT formula. So the growth constant to 4 significant figures. So what I'm going to do, and I need to do this in the calculator, of course, I'm going to type in natural log 26,050 divided by 22,353 and then divide it by 10. Okay, to 4 decimals would be right here. So my k would be 0.0153. Now, final answer is not the k value. The final answer is your exponential model. So remember, before step 2, before I plugged in, I had this as my exponential model. So now step 3, the final step 3, is I go back to the end of step 1. So back in step 1 where I had this exponential model, okay, and I simply combine what I found in step 1 and what I found in step 2. So in step 2, I actually identified what that k value is, so I plug in that k value. So this is going to become y equals 22,353 e to the 0.0153 t. So basically step 3 is to combine what I had in step 1, final answer, what I had in step 2 into my exponential model. And that becomes our answer that we're going to type in for the homework. That represents our exponential model.